Alright, so this is, hopefully it's obvious that this is still 3-2, but I better make sure that's clear. 3-2 was broken up, like we're covering 3-2 over the course of at least 2 classes, so at this point in time we are like halfway completed or whatever ish, halfway-ish done with the notes, and we're kind of picking up, for the second half of 3-2. And in the first half of 3-2, we learned the substitution method for solving systems of 2 equations. And that was an improvement over the graphing method. Again, not that the graphing method is awful. Graphing method is perfectly good, but sometimes the graphing method can be like a little bit lacking in accuracy and reliability. So we had the substitution method. Well, guess what? We just learned that it is possible to solve linear systems algebraically with substitution method, which is far more dependable, I just said that, than the graphing method. And if you think that is the only algebraic method there is, then you are sadly mistaken, for there is a second one. Man, you have so many options. For there's a second one. Behold the elimination method, which I sometimes like to refer to as the addition method. So here's an example, a whole other method to teach you. Okay. So we have this system which has an equation of 4x minus 2y equals 7, and another equation that says x plus 2y equals 3. Now, the idea behind this method is to eliminate one of the variables by adding or the equations together. By doing this, we are able to solve for the other variable first, which is kind of similar to the substitution method. Remember, in the substitution method, after you did that substitution step, you'd like have gotten rid of one of the variables for a second, which allowed you to solve for the other one. You know what I mean? This is going to be very similar. We want to kind of pull some algebraic, tricks from up our sleeve, so that we can kind of like eliminate. Here we're like literally calling it that we're eliminating one of the variables so that we can, solve for the other one. And we're gonna do this by, in the last lesson we did it by a whole like substitution trick. Here we're going to be doing it by adding the equations together, or I'm not gonna pretend that this whole thing doesn't exist, especially since you might have learned it in like Algebra 1. You can also technically subtract the equations, but I like to focus only on adding. I just feel like when you open up that door for also subtracting equations, it can just lead to more mistakes. But hey, I'm not going to stop you, but I'm going to focus only on adding the equations together in order to eliminate one of the variables. So how are we going to do that? Well, let's investigate. Oh, step 0. Step 0. Make sure everything is lined up. What do I mean by that? Well, actually, take a look at this example here in blue. What I mean by lined up is that, it looks like both of these equations are in like standard form, where the x's are lined up first, and then followed by the y terms, and they're lined up. and then followed by the equal signs. Those are lined up, and then followed by the number constants, like the regular numbers on the other side. So everything's lined up, because think about it, if we're going to be, if the overall strategy is to add the equations together, don't kind of like isn't it like nice if the like terms, they kind of need to be lined up. So that's step 0. Make sure everything is lined up, x's, y's, equal signs, number constants. Now, if the idea, this makes almost too much sense, right? Are you ready? If the idea is to have one of the variables be eliminated after we add the equations together, don't we need to make sure that there is a pair of what? Opposites contained in the like terms. Think about it. That's the only way you're actually going to eliminate either x or y. You know, when you add, like look down here, I might be getting a little ahead of myself, but not really. When you add 4x and 1x, 4x and x together, are the x's going to be eliminated? No, that's going to be 5x. But negative 2y plus 2y, these two terms completely cancel out because they are perfect opposites. And so that's what we need. So step 1 is, again, to kind of just revisit step 1 and read it again, just to make sure we get it. Make sure there is a pair of opposites contained in the like terms. Now, maybe you can add up here, maybe I should get a little purple, x's or y's. The x's have to be opposites, or the y's have to be opposites. So now that we've actually confirmed, hey, that's nice, this problem already has the y's as opposites. So step 2 is then to add the equations together. And then, the whole like subtract deal is the rest of this, but I'm going to ignore that. So, so that gets us, well, I might as well write it down here. It'll be okay. So, so we add the equations together. So 4x plus x is 5x. And then these cancel out. And then we have the equal sign, and then 7 plus 3 is 10. Now look at this very simple equation we've now ended up with. 5x equals 10. We could totally solve that for x. So step 3, solve for the remaining variable. So this is what I was talking about when I said if we eliminate one of the variables, we can now just solve for the other one very easily. So dividing both sides by 5, you figure out that x equals 2, which is basically like half your answer. Because what else do we got to do? We know what x equals, but don't we also have to know what y equals? So step 4, which I'm going to, just so that we can see the whole thing, even though it's right on your paper. Now that you know one of the variables, solve for the other one. And we're going to do that like the same way we did it in the substitution method. So pick either one of these. It really doesn't matter. Now that you know that x equals 2, you can plug in 2 for x somewhere and solve for y. And it's like you have your choice. And so, you want to choose what you think is going to be the less complicated equation or the easier equation. And I'm going to pick the second equation, even though you could totally pick the first one. It doesn't matter. But I'll even write it out again before I substitute. But remember, now I know that x literally equals 2. And so now I can solve for y. Like now I find myself in just the kind of mode or the kind of gear where I have this equation and I can actually solve it for y. So subtract 2 from both sides, end up with 1. And then when you divide both sides by 2, you end up with 1/2 or 0.5. Either way is good. The decimal equivalent here, you don't have to round it. It's a nice 0.5. So that's the final answer. You could summarize it as 2 comma 1/2. And that's the basics of the elimination method. You're going to be adding the equations together once you have opposites that'll cancel out, which will allow you to solve for the other one. And then that, in turn, you can kind of circle back to solving for the other variable once you know one of them. So example A here. This one would be one where you might want to pause the video and you can totally do this one on your own. Try this one on your own and then unpause. But so I'm going to do this one in 3, 2, 1. Okay, so when I look at this and I think about maybe doing the elimination method, first I have to check to see that everything's lined up. Okay, so the equations are lined up. Next, I'm going to be making sure that there are opposites, so that I can go ahead and add the equations together. So 3x and 2x, positive 3x, positive 2x, not opposites. Negative y or negative 1y and positive y or positive 1y, those are opposites. So the y's, again, turn out to be opposites. So since there's opposites, I can go ahead and add these equations together because these are going to cancel each other out totally, and I'll be left with 5x equals positive 5 because 7 plus a negative 2 is positive 5. And now I can be freed up to solve for x. And so x equals 1. Now I take this answer and use it to figure out the other variable. And once again, when I look at equation 1 versus equation 2, I'm going to choose equation 2. It doesn't matter, but I see that this has a positive y and that has a negative y. I mean, it doesn't matter, but I think this will be a little less messy. But here's the thing, now I know that x literally equals 1. Ooh, I almost forgot the negative there. So 2 times 1 is, of course, 2. Hey, come on. What is going on? My board is freaking out. And so now we would subtract 2 from both sides and end up with negative 4. So it looks like our final combined answer, remember it always goes x comma y. And I know most of the time here we've been solving for x first, but sometimes you solve for y first. Either way, in this final answer, it's got to go x comma y. All right? So that's that example. Now this one, once again, I think this is one where you can pause the video, try this on your own. Last warning, because I'm going to go ahead and do this in 3, 2, 1. Once again, everything is lined up, and it's like, to kind of go a little long-winded here for a couple seconds. I mean, it's probably rare that you're going to choose substitution. It's probably rare that you're going to choose the elimination method if the two equations are not all lined up nice, like both basically in standard form. If everything's not all lined up, again, chances are you're probably not even going to choose. I don't know. Maybe I shouldn't say that. But I guess, I don't know. So then maybe never mind. The bottom line is everything's got to be lined up, which here it is. Now you also need opposites. Again, you are not going to add the equations together. It's pointless. It's pointless to add the equations together unless you know that either the x's or the y's are going to cancel out. That's why you need opposites. Negative 4x, positive 4x. Ah, those are opposites. So the x's are going to cancel out. The y's are not. Negative 9y and positive 6y, those are not perfect opposites. But since the x's are, they're going to cancel out, and I can go ahead and pull the trigger on adding these equations together. So negative 9y plus 6y is what? That's right, negative 3y. And what is negative 1 plus negative 2? Well, that is negative 3. And now I'm going to be able to solve for y. Very simple equation that you can now solve for y, because you can. Divide both sides by negative 3. Of course, to get y by itself, I don't know why I don't like that. It's too messy. That's all. That's it is better. Negative 3 divided by negative 3 is positive 1. So now I know that y equals negative 1. And I can now use that and plug it back in somewhere and solve for x. So which equation up here do you think would be? They're both going to be okay. But which one would you choose? Maybe you chose, it doesn't matter, but I'm going to choose the second equation. Looks a little bit nicer. I don't know. So now that I know that y is literally the same as 1, I can they're interchangeable. I can replace that in there, which is going to open up the door to now solving for x. So I just kind of go with this, solving for x. So that leaves 4x over here. Negative 2 minus 6 is negative 8. Divide both sides by 4 to finish getting x by itself. So it looks like we end up with x equals negative 2. So my final answer, like I just said a couple minutes ago, goes x comma y. So it's negative 2 comma 1. Okay, so that hopefully laid a really good foundation. That handful of examples. Our original example, and then A, B, and C. Oh, never mind. Just like 3 overall. So hopefully those 3 examples have laid a really good foundation, because now we're going to take the next step. Question: what if the system given is not already perfectly set up so that one of the variables will be eliminated when you add the equations together? Add, or subtract. In other words, what if there's not opposites already? Like, look at this example. Everything's lined up. Okay, that's a good start. Everything's all lined up. But the x's, positive 2x and positive 3x, those aren't opposites. And then the y's, positive 1y and negative 2y, those are not perfect opposites. So it would be pointless to add these 2 equations together because nothing's going to cancel out. So what do? That's the main issue here. What do? Answer: alter one or both of the equations so that one of the variables will become opposites, or so they are going to be opposites. Okay? Now, how do we do that? As you think about that and finish writing down what's in pink there, so I'll pause a little bit. But so think about that. What are we allowed to do in order to alter one of the equations or maybe both of the equations? How can we like rewrite or change the equations so that like we've done something legal, but we've sort of like updated the equation or both equations so that we do have opposites? How do we even do that? What are we allowed to do? Well, the answer is we are allowed to multiply the entire equation by whatever we want. Because remember, you can multiply something as long as you do it to both sides of an equation. Essentially, that means like you're going to be multiplying it to the entire equation, to both sides of the equation, which will change the numbers. It'll still be basically essentially the same equation, but so we're going to do this by multiplying. Alter one of the amazing. So maybe right here, I was going to say with, but by multiplying okay, and so here we go. So we have the x's. We could change the x's, right, so that they're up, but I'm going to see here that, well, the y's are already different signs. This is a positive 1y. This is a negative 2y. At least they already have like different signs. Like that's something. So let's make the y's into perfect opposites. Now, I could change this 1y into something else, or I could change this negative 2y into something else, or I could change them both into something else. As long as after I do this, they are opposites of each other. You know what I mean? So again, it's like, what would be like the least amount of work? What would be the simplest, path here? And I look at this and go like, I can totally make this term into the opposite of this term. Like, what would be the opposite of negative 2y? Well, obviously, positive 2y. So can you make this term into a positive 2y? Yeah, very easily. By multiplying by what? By 2. Okay? So I'm going to multiply this remember, it's got to be the entire equation, technically both sides. Multiply the entire equation by 2. I'm going to be able to actually leave this equation as is. So again, the entire thing. So this becomes a 4x plus 2y equals 10. And the second equation can stay the way it is. And now I have opposites. So I can go ahead and now add the equations together and have the y's drop out, and the rest of it becomes 7x equals positive 7. And yada, 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 like before. And so we end up with x equals 1. All right? And again, the rest of this is just like it's always been. Now I can take my answer, plug it back in. Now I have this choice, I have this option, or I actually have like my updated equation number 1 if you want to do that. It doesn't matter. I'm actually going to choose the original equation number 1. And so 2 times 1. I mean, I hope you can see why. I mean, look, that's just like a simple 1y here that I'm going to be solving for. It doesn't matter which equation you chose, but, you probably want to think smarter, not harder, So plugged in there, so now that becomes a 2 plus y equals 5. Subtract 2 to the other side, and you end up with y equals 3. So my final answer is pretty clean. 1 comma 3, and that's what you do. You have, if there's not already opposites to begin with, you have to make opposites, and again, you know, at this point anyway, you might be thinking like, well, how do I know how do I know which equation and what do I multiply by? And I wish there was a perfect answer that always applies, but because pretty much you got to multiply by whatever it takes. You got to multiply by whatever is going to make the opposites you're looking for. Here, I wanted to turn this into a 2y so that it was the opposite of this, so I had to multiply by 2. You multiply by whatever's going to get the job done. So I guess we are moving on to like the next level of difficulty here. Because check this out. Everything's lined up. There's not opposites. Positive 3x and positive 5y. Positive 7y and positive 2y. Not opposites. So we have to make opposites. Now, could I multiply 3x by something in order to turn it into like the opposite of this? So can you make a 3x into a negative 5x? I mean, you could, but you'd have to use like fractions. So like, no thanks. Likewise, look at the y's. Do you think you could multiply this by something to turn it into like a negative 7y so that those are opposites? Again, you could, but you'd have to use like fractions and no thanks. So here's what I'm going to recommend you do in situations like this. Remember, like I hinted strongly here, you're allowed to change both of them so that they both change and so they meet up as opposites. So let's eliminate x. All right? Let's set these up so that the x's are going to be eliminated. So I can't change 3x into a negative 5x without getting messy. But what could I change both of these into? Like I could change a 3x into like a 6x or a negative 6x, a 9x. Like I'm thinking of like if I multiplied by 2, if I multiplied by negative 3 or negative 2, right? And I'd have to multiply the 5x by something, So it's like, what would be like a least common multiple? Or what Mr. Birchnowski does, just to be safe, if you multiply each one of these by the other one, they're going to be the same. And, other than that, you just have to make sure that they end up having opposite signs. So what I'm saying here is we can multiply the 3x along with like the rest of this whole equation by 5. And the second equation I'm going to multiply by 3. But again, if this is going to become a positive 15x, I need this to become a negative 15x. So, I'm actually going to multiply by negative 3 because, again, they need to end up not being exactly the same but opposites. Okay? So, this becomes, the first equation ends up being positive 15x plus 35y equals 75, I do declare. And then the second equation becomes negative 15x minus 6y equals positive 12. And so the x's are opposites. They're going to eliminate and cancel. And so I get 29y, positive 35y, negative 6y. and here I get 87. So now that I have a very simple equation that I can solve, I do that, and I get y equals 3. Y equals 3. And now I can choose any one of these 4 equations. I'm going to choose the, I don't know, just to kind of, I'm going to choose equation number 1, the original one. Not that I don't think it's going to mean too much either way. So I got to solve that. 7 times, so now I know y is 3 equals 15. So 3x plus 21 equals 15. When I subtract 21 out of there, I end up with 3x equals negative 6, and then you divide both sides by 3. So your final answer is negative 2, comma 3. Now let's start all over again, knowing already what the final answer is. But let's, what if we chose to eliminate the y's first? I mean, that was obviously an option. So pause the video and and try this by eliminating the y's first. And I will run through this in 3, 2, 1. All right, so like Birch would say, if we multiply each one of these by the other one, they will become the same, and then just other than that, you have to make sure they have different signs. So I'm going to multiply the first equation by 2, and that's going to turn that into a 14y. And here, this one's also positive, so I can't just multiply by 7. I have to multiply by negative 7. So that this becomes a positive 14y, and this becomes a negative 14y. But again, you're multiplying the entire equation by that number. So it becomes 6x plus 14y equals 30. And this other equation becomes negative 35x minus 14y equals, so negative 4 times negative 7 is positive 28. Now I'm good to go to combine the equations, to add the equations. Dude, you came in really quietly. Mr. Birchanowski's here, everybody.
Ladies and gentlemen, the Golden Apple Award winner himself. It's a beautiful problem you have going, Mr. Falk. I like how you eliminated the y's. That was very intelligent of you. I would have gone after the x's, but that's just me.
You mean back like we did back here?
Yes.
We're doing it both ways.
I like it.
I actually name dropped you because
that happens a lot.
Multiplying each one by the other one?
Yeah.
Works every time.
The old thumb method we do.
Dumb.
Thumb, not dumb. Thumb. So that would be negative 29x, Mr. Falk, is equal to 58. We're going to divide both sides by negative 29. And we, ladies and gentlemen, get x is equal to negative 2. Did all that math in my head. Now, we're not done, though, Falky. Don't you stop right there, big dog. We're looking for where these lines intersect, right? We only have one coordinate, the x coordinate. How do you find the y coordinate? Don't yawn at me.
Well, which one would you choose? As I've been saying, you could choose that equation, the new versions of them.
I would choose the second one, 5x plus 2y is equal to negative 4, because I feel like it's a little smaller with the numbers, the coefficients in front of the variables.
Yeah, make smarter, not harder. Like
yeah, absolutely. Be a thinker, not a
stinker.
Very good.
What movie's that from, everybody?
I don't know. I just heard it from you.
You know what it's from.
Here, I'll finish this problem. Keep going. Negative 10. plus 2y equals negative 4. We're going to add 10 to both sides. Mrs. Bailey would be happy keeping the variable on the left side. 2y is equal to 6. Divide both sides by 2.
What the heck is happening right
Y is equal to 3. Yeah, but what does that mean? So I got negative 2 comma 3. I don't understand. What does that mean?
Like, what does it mean that it's a solution to
Yeah,
this system?
yeah. What's it mean, Mr. Falk?
It means if you plugged in the negative 2 in for the x's and the 3 for the y's, it would make both equations true at the same time, or graphically.
Yeah, that's what my next question was. I'm a visual person. You know me. Visually, what would happen? What would that negative 2 comma 3 mean?
Means if you were to graph both of these equations in the xy plane, those two lines would cross or intersect at negative 2 comma 3.
Is there ever a time where you're going to solve one of these where they never have a point of intersection?
Oh yeah.
Oh, am I stealing your thunder a little bit right now?
Nope.
Okay.
It's actually going to be, but I'm actually going to take a break, and this will actually be continued in another video. So,
I will not be there for that video, ladies and gentlemen. I will not be there.
say goodbye, Mr. Birch.
Goodbye. I hope you have a great day.